Hello. Today we're going to talk about what a research population is, what sampling entails, and different types of ways we can sample from a population into our research studies. So I'm going to share my screen. And here we go. So these are the objectives for the lecture today. Understanding the difference between a population and a sample, and between probability and non-probability sampling, okay? Now, what is a population? Well, if you think about the Australian population, that's combined all of the people who live here, all right? So a research population would be very similar. All of the people or items like cities or units that you want to examine, all right? It could be physical people, or it could be something more abstract like an institution, a building, but it's a large group of things about which you want to make conclusions in your research, all right? So the population is very important. Now, obviously, it's not feasible to collect data on every member of a population. Trying to do that in Australia, that would be more like a census, trying to get information about every person that lives here. In most research, we don't need the entire population. What we can do is rely on sampling. And there's a lot more science behind it than you might think. So if we have a big population, say 25 million people in Australia, and we want to know who's going to vote Labor or Liberal in the next election, we would sample part of this population. And therefore, we would hope that we could get some really predictive information from a small subset or sample of that population, okay? Now, when we choose people to be in our study or to take our survey or to get data from, we call this sampling, okay? That means we're selecting individual units from that larger group to be included in our study. Now, you might hear this term sampling frame, and that means it's a complete list of all the elements in a population from which the sample is drawn. This could be like if I'm doing a study of all students at Griffith College. The sampling frame might be all 3,000 enrolled students, but I wouldn't need information on every single one. I could just choose 100 students from that list, and that would become my study sample, okay? So population is big. It's everybody. It's the entire group about which we want to make conclusions in our study. And a sample is a small subset of those people that we include to collect data on. Now, the reason we use sampling is because we want to be able to say we've got reasonable certainty that the information we found from the sample is reflective of the population, okay? Now, how do we decide who will be in a sample? If we've got 25 million Australians, it might be really difficult to figure out how many people to include, or which people to include, or where we should find them. All right, now there are different methods we can use to make the selection of who goes into our sample, and this is called sampling methodology. All right, now you might say, well, shouldn't we just get all the information from as many people as we can? Not necessarily. All right, sometimes large sample sizes are really good, especially having statistical power, but can they give us valid, predictive information about the larger sample? So in a sense, can that sample really represent our larger population? Okay, think of it this way. If we want to make generalizations about people in prison, now we know people are in prison for all kinds of different reasons. But let's say we only sample 3 people out of everyone incarcerated, and these 3 people happen to be murderers. Would their experiences necessarily be reflective of every other type of person in prison? People in prison for fraud, people in prison for assault, people in prison for other non-violent crimes, or people in prison for sexual crimes. So if we only choose 3 people from the entire population of prisoners, we want to make sure that our sample is as predictive as possible or as representative as possible. Now, if we're thinking about a unit of analysis, what does that mean? Well, really it means it's the thing that we're going to analyze or the things we're going to compare. Now, a unit of analysis means what are the people or the organizations or the units in my study, in my sample. We could have individuals as the units of analysis. One study might look at individuals like who is more or less likely to have punitive attitudes towards drug offenders. That could be people. All right, we could have countries as a unit of analysis. If we're doing a comparative study on the punitivity of different countries like Australia and America, maybe some countries in Europe, then we wouldn't be looking at individual people. We'd be looking at the country as a whole, each different country being the unit of analysis. We could talk about institutions like the educational institution, healthcare institutions. Which institutions are more or less likely to respond punitively to drug offenders? That could be a research question in which I examine institutions as my unit of analysis. Or finally, events. That could be a unit of analysis too. Which events drug offenders are more or less likely to use drugs at? Music festivals versus doctor's appointments. These sorts of ideas would fit very nicely within a sample because it's representing larger population of things that are happening, but the unit of analysis itself does not have to be just individual people. Okay, so we use probability sampling when we really want to get a good representative sample that reflects our whole population. All right. When we say probability, think back to your 7th grade math. All right. What's the likelihood that you're going to roll a 1 if you roll a dice? That would be 1 in 6. Now, every face on that dice has a probability of coming up, and each probability is equal. All right. So when we say we're looking at a probability sample, that means that every member of the population has an equal chance of being selected for my sample. Now, why is that important? Well, it means that this is not going to be biased, and it means that there is a known probability of being included in the study, and therefore it makes it more likely this sample will be representing the entire population, and it wouldn't be as biased, okay? Now, we say probability samples are more accurate than non-probability samples because they tend to remove our conscious and unconscious biases. That means we don't just pick people who look like us or who might speak our language or whatever our biases might be. And then we can ensure the accuracy, or we can, estimate the accuracy of the sample because we probabilistically sampled. Okay, now let me talk about what this means and how we get to probability samples. Now, we have several types of probability samples. And again, this means that each member of the population has a known chance of ending up within the sample. Now, you might have heard of something called a random sample or random sampling. And this is where that is explained. A simple random sample, or SRS, you might see that in the literature, is exactly what it sounds like. Let's say every member of our class, I took all of your names and put them inside of a hat. And then I drew out 5 names and I say, oh, randomly I'm going to choose 5 students and they need to present on a topic next week. That's as simple as it is. It's simply and randomly selecting members from the population to be included in our sample. You can see on this graph up here, that's what that might look like, okay? Another common probability sampling method is the systematic sample. So it's still selecting at random, but in a systematic fashion. All right, so every person on a list might have an equal chance of being included in the sample, and we might select every third person. Okay, so imagine if we sat around a table and I told you all to count off in numbers: 1, 2, 3, 1, 2, 3. Each person is assigned to a group systematically. So it's no longer just choosing things out of a hat, but it's based on where you're sitting. Now, I'm ensuring there's no bias here because the list already exists, or the people sitting at a table already exists. Now, it may give everyone from the population an equal chance because the list has no particular order. So we call that a systematic sample, and sometimes that's easier to do than a simple random sample, okay? Especially if we're dealing with lists, like a phone book. Now, there are other types of probability samples as well, and these get a bit more complex. We can talk about something called a stratified sample. Now, what this means is it involves dividing population into groups or strata based on characteristics, and then randomly sampling from those stratum. So the plural of that word is strata, and stratum would be the singular. Now, what do you mean, Mayessa, breaking groups into strata? Okay, well, this means we could break individuals along lines of an independent variable, like race, okay? White, non-white, that could be 2 strata. We could break along SES, upper class, middle class, and lower class. All right, we could break upon levels of education. If you imagine an independent variable that can be broken into levels, so break it upon those attributes, then we would consider those strata. All right, first child, middle child, and youngest child. 3 different ways here. Now, why would we do this? Well, it's useful when we're trying to determine differences between 2 groups and one or more of the groups is small. So let's say in Australia, we're looking at the Australian population and we want to make comparisons between Indigenous Australians and non-Indigenous Australians. Well, we know that the Indigenous Australian population is much smaller than the non-Indigenous population. So we might tend to break our sample. About 95% is non-Indigenous, or a population, 95% is non-Indigenous, and 5% would be Indigenous. So from here, I've got 2 groups, and then I can randomly sample from those groups. And that means the chances of including Indigenous Australians within my sample are increased. And that would be important to me and my study. So I'd want to make sure and capture Indigenous Australians. Now, it can also permit us to get more people in that small group, and we can do some math and fancy statistical corrections to make sure that they're not overrepresented, but that we're drawing really good connections, okay? And that our conclusions are valid. All right, so when we're thinking a stratified sample, we're breaking it into strata, usually upon an independent variable of interest, race, SES, Indigenous status, level of education, whatever you think is important in your study. And then from each of those different strata, we're randomly sampling from those, okay? Here's a visual example. Let's say we had 500 grade 4 students at an elementary school. Now for my sample needs, I'm only going to need 100 students. But I want to break them into a strata upon an independent variable I think is important. And in this study, it would be motivation. I want half of my 100 students to be highly motivated and the other half to be lower in school motivation. All right? So what I might do is take that population of 500 students and break it into those relevant groups or strata. And as you can see here, I might find I have 300 highly motivated students and 200 low motivated students. And from those groups, I can then randomly sample 50 students from each. So even though one group is smaller than the other, I'm showing equal representation within my sample. Now, there are other types of probability sampling as well. And remember, probability means that each person in the sample or each person in the population has a known chance of ending up in the sample. Now, we have something called a multi-stage sample, and that involves randomly selecting clusters within a population and then randomly selecting elements from each cluster. So here's an example here. All right, from America, from the home state of Texas. We might be looking at middle-class working couples problems, all right? The first stage in this multi-stage cluster sampling exercise would be to pick up a few districts in a state, all right? So as you can see here, we might find District 1, 2, and 3 in Texas. And then within those districts, we can break them into another strata, rural area and an urban area. And then from those strata, we can randomly sample middle-class families from these areas and picking working couples, okay? So the people that meet criteria for inclusion in the study. Now, what's the advantage here? Well, it's useful when we need to interview people at different locations who are clustered into certain groups. And again, that's dependent upon the IVs you're interested in breaking your groups into. Local example, if we wanted to study university students all over Queensland, well, I live in Brisbane and it would be tough for me to get up to James Cook University and sample students from up there. So I might identify a few universities around Queensland and then fly up, sample my students there and come back down, so that I've got equal representation of university students all over Australia. Now here's a summative table of advantages and disadvantages of using these types of probability sampling methods. So I'm going to stop sharing my screen now. And hopefully now you can understand about what a population is and about probability sampling methods. In our next lecture, we're going to talk about non-probability sampling methods. All right, see you soon.